Hello, welcome back once again, all my dear students of 9th standard. Again, I came in front of you, not we. I came in front of you to discuss about the last part of our first chapter of chemistry of 9th standard science, and of course, it is matter in our surroundings. Okay, the matter which is existing in our surrounding. We have learned a lot of properties of matters. Basically, we can divide this matter into three types, and they are: one is solid, liquid, and gas. You know the properties of solid, liquid, and gas in detail. Okay, that question answer is also there from textbook regarding that. So very simple of that. After that, we came to know about what change of state. How a matter can change its state. Mostly if we heat it, it will change its state. For example, fusion, solidification, vaporization, condensation, and sublimation. So these are the different types of states when we are applying temperature to this matter. But in this class, what we are going to study, effect of pressure. Okay, didn't made a mark, but effect of pressure. What happens if we apply pressure to a matter? So just as revise it. So solid, when we apply heat, it will fuse into forming liquid. Again, if you are applying heat, that liquid will vaporize to become gas. And if we cool down the gas, it will become condensed and form back liquid. Again, if we cool down or freeze the liquid, it will change into solid form. Okay. So, and the conversion of solid into gas directly without becoming liquid is called as sublimation. And the conversion of gas directly into solid is also known as sublimation. Mostly this sublimation occurs when we apply pressure. So the next point is about what is the impact. Okay, what is the impact of pressure during this conversion of matter into different forms? Okay, the first point. When pressure is applied on a gas particles, it will come closer and gas changes into liquid. Just remember that example of that compression of syringe. Understand? Compression of syringe. When we compress that piston of the syringe, what happened to that air which was inside? It will also compress. Understand? That volume of that particular syringe, it will be reduced. When it is reduced, automatically you can understand that space between that particles also comes near. Where is the diagram? I think I changed that. Okay, let me fetch it. See, when we increase the pressure, I will put it. It will be interesting for you. When we increase the pressure, what is happening? This space between these molecules of air or gas, it will come near. At a particular point, what will happen? It will be equal to the space of that of liquid. At that time, gas will change into liquid. And again, if we apply more pressure, what will happen? It will change into solid. Understand? So regarding this chapter, effect of temperature is more important than effect of pressure. Effect of pressure is for higher studies. Okay, we can liquefy gases by applying pressure and reducing the temperature. A very good example is there. Liquefying gases means we can make gas into liquid. A very good example is your LPG gas cylinders. Understand? LPG gas cylinders. Anyway, all of you will have a gas stove at your home. So that you are using these LPG gas cylinders. If we just shake that cylinder, we can hear that squashing sound of liquid. Right or not? If we just shake that cylinder, we will hear that squashing sound of liquid. So that means inside that cylinder there is some liquid. But the full form of LPG is liquefied petroleum gas. LPG, liquefied petroleum gas. Actually, LPG is gas, butane. LPG is butane gas. But it is in the compressed form. That's why it behaves as liquid. Understand? And whenever we open the valve of that gas cylinder, what will happen? Because of diffusion, that compressed LPG from that cylinder will come out in the form of gas. Understand? The same thing is happening when we are cooking with that gas stove. That compressed liquefied gas from inside that cylinder is coming out through that pipe, and it will connect the burner of our cylinder, not cylinder, burner of our gas stove, and when we burn it, it burns and it cooks the food. Understand? So when we apply more pressure, what will happen to this gas? It will change into liquid. Okay, if we compress carbon dioxide into very high form, it will also act as solid. So it is called as dry ice. Leave it. That's all our examples I will give directly in your CW regarding that. Okay. So the last portion of this chapter is about an interesting topic called as evaporation. You know why evaporation is that much important for us? You know why? Lots of application of evaporations are there. For example, rain, isn't it? If we wash the floor of our room, understand? If we wash the floor of our room with water, and after wiping that water with a cloth, even after that, some particles, some amount of water will be there in that floor, isn't it? Am I correct or not? Anyway, we cannot wipe all the water from the floor. Some amount of water will be in that floor. So, morning time you just look into the room, there was some water in that room. Lunch time you are coming back to that room. The water disappeared. How? If the water want to disappear, you must, that water if changes to vapor, it will disappear. To change it to vapor, you must boil it. Am I right? Anybody boiled that water? No? I think no. One more example is there. Anyway, you have clothes, isn't it? We are washing our clothes. To keep it clean and neat, we are washing this with water. And when after washing, there must be some amount of water inside this cloth. Isn't it? We want to make it dry. If you want to make it dry, just turn this into vapor form. Then turn that water into vapor form, it will become dry. Isn't that? So that you are going to boil that cloth. You are going to boil that cloth. No. Just you will place it in open sunlight or somewhere outside. So that process which makes that cloth dry, the same process which makes that floor dry, that process is called as what? Evaporation. Understand? The change of liquid form of water into vapor form, but below boiling point. That's the main point. Below boiling point. Below boiling point. This point is very, very important. Just keep this thing in your mind, my kids. This one. Okay? Below boiling point. At room temperature also evaporation is occurring. At room temperature also. So that is called as evaporation. Understand? We don't want to boil our clothes to make it dry. We don't want to boil our floor to make it dry. It is because of one such process called as evaporation, and it occurs below the boiling point of water. Understood? So why is evaporation is important? One of the biggest phenomena in the world, rainfall, is occurring due to evaporation. You studied in smaller classes, isn't it? Yes, the water from the lakes, rivers, sea, wherever it is, what happens to it? It will evaporate. In common day temperature, it will evaporate and it will become water vapor. And the water vapor, it will go up, and when it condenses, it will become water droplets and it fall down as rain, isn't it? So that is the importance of evaporation in our daily life and all. So what are the factors affecting this evaporation? What all things will affect, or what all things will help this evaporation? What all things? Any guess, any clue? For that, I will try one example. I think it is in the textbook. Not given here. Okay. One example I will tell. Just think that you have water with you. Okay, you have lots of water. Water is very cheap. You have a lot. You have one test tube. You have two test tube and two plates. You got two test tubes and two plates. Fill the plate with water, fill the test tubes with water, and one test tube keep in the side of the room. Near to that test tube, keep one plate. Understand? And one test tube and one plate, take it and keep it outside in sunlight. Okay. Morning time you just keep it, and evening time just come back and just see what will happen. Which vessel will be, water from which vessel will be evaporated totally? The one which we are keeping inside the room? No, one which we are already kept outside the sunlight. Okay, outside in sunlight, because evaporation, whenever there is temperature, evaporation rate will increase, isn't it? But we kept that test tube and that plate also there. Both we filled with water, but the plate is almost dried out. But the test tube, only that water level increases a bit. Decreases a bit. What does that indicates? Okay, evaporation is also a surface phenomena. This one also, just keep it in mind. Evaporation is a surface. It is a surface phenomena. Mostly evaporation occurs only in surface. Understand? That's the difference between boiling and evaporation. During boiling means from every part of that water, it is boiling, vapors will come out. When you see that, if you are boiling water in a vessel, have you seen that bubbles coming out of it? Seen or not? Just keep a utensil in your gas stove, pour some water, heat it. During boiling time, you will see bubbles coming out of it, isn't it? So, water vapor, this boiling does not happens only in the surface. It happens throughout the liquid. But in the case of evaporation, it is a surface phenomena. If we increase the surface area, evaporation rate will be high. That's why while drying our clothes, we are making the clothes wide open. Understand? We are making the clothes wide open. We are not crumbling it and hanging there, isn't it? We are making it wide open so that the maximum area will be outside, so that much amount of evaporation will happen and the clothes will be dried out soon. Understood? So it is a surface phenomenon. Let's see what are the factors affecting evaporation. The rate of evaporation depends upon the surface area, temperature, humidity and wind speed. Understand? If wind is more, then also evaporation takes place very high. Humidity. If humidity is high, evaporation will be low or high? Evaporation will be low. Isn't it? Presence of moisture in the atmosphere. Okay, when more moisture is there means it will be difficult for these water molecules to change into vapor form. Surface area. If the surface area increases, evaporation increases. If temperature increases, evaporation increases. Temperature increases, rate of humidity increases, the rate of evaporation increases in the wind speed increases. Okay, this is the common thing about evaporation. Okay, one more time I will tell the factors affecting evaporation. The surface area of the water. The surface area increases, evaporation increases. Second one, temperature increases, evaporation increases. Third one, humidity increases, evaporation decreases. Understand? The last one is wind speed. If wind speed is more, evaporation will be more. That's why during cloudy days, what your parents are doing to dry the clothes, they will place your clothes inside the room and they will switch on the fan. Because more wind will increase the evaporation rate and your clothes will be dried out very soon. So these are the main points about that. Okay, let us see this diagram. It's a common diagram regarding evaporation. So how this evaporation is actually occurring? I told that latent heat of vaporization, the particular heat in which 1 liter of water is changed into vapor. Understand? So in evaporation there is 3 types of molecules. Molecules with low energy, medium energy and high energy. Okay, during evaporation what will happen? In a common day, when this water we keep outside, these molecules with medium energy, that molecules are in the surface of the water. Understand? They are in the liquid form, but they have a medium energy, and whenever they gains enough energy, they will become gas. Understand? Understood? So, and the molecules which is under the water at the bottom, they have very low energy. They won't become gas. Understand? Slowly, slowly they will go upside and they will form the surface of that water. And whenever they are getting enough energy to become a gas, they will escape from the surface and becomes gas. Understand? Here the gas is water vapor. And some part of energy they must get. From where does they are getting this energy? This energy, I told, if this molecules, water molecules, want to escape like gas, they must get some energy. From where they are getting it? Actually, during evaporation, they will absorb this energy from the atmosphere. Understand? Mostly heat energy from the atmosphere. That's why when evaporation occurs, mostly that area near that evaporation, it will be very cool. Understand? When you are going near a river, if you feel some coldness there, it's not because the coldness of the water, it's because of evaporation. Understand? Because of the evaporation. The same thing is happening. If you take one bottle of cold water, what will happen? Small water molecules will come and stick on the wall of that bottle, isn't it? How? Because during evaporation, these water molecules is absorbing energy from the moisture in the atmosphere. That's why that water vapor in the atmosphere will become common water by releasing the energy, and it becomes common water. All the notes are also there. When I give the notes, you will understand more about these things. And the evaporation causes cooling. Okay, one example is an electric cooler. It uses the same technology, not technology, same application of evaporation. Okay, desert coolers and all. Have you seen coolers? In this area, I think this cooler is not that much. Mostly in desert areas, we can see coolers. What will happen? This cooler, there will be a sponge is there. In that sponge, they will add some water. They will dip that sponge in water and they will rotate a fan in the other side. So what will happen? This fan will, the wind will increase the evaporation and cool wind will come outside. And the surrounding area of that sponge, it will absorb energy from the atmosphere. So that what will happen? The temperature of that surrounding will come down and we will get cool air out of a desert cooler. Okay, that is some application level question. Application level questions like that, if you study means you won't understand. It's directly given textbook. Anyway, I will give you note also. I hope that's the end of this chapter. This chapter, these properties of three different states of matter is important. Solid, liquid, and gas. And this diagram also is in reason. Many times this is asked. They will just draw this arrow mark, but they won't give you this. Okay, you want to write this, you want to guess and you want to write. Sublimation is very important, evaporation also important, application of evaporation also important, surface area and also important. Matter is one more question, and latent heat of fusion and latent heat of evaporation also important. And there is one more chart is there regarding the standard unit. Okay, standard unit of mass is kilogram. Standard unit of mass is kilogram. Standard unit of weight is Newton. Standard unit of volume is liter. Standard unit of temperature is Kelvin. Okay, and one more thing is there, absolute zero. Absolute zero means 0 degree Kelvin, which is minus 273 degrees Celsius. It's a very cold temperature. Understand? In 0 degree, ice will become ice. Water will change into ice. Just imagine minus 273 degree. That much cold. Okay, that's called as absolute zero. All those things like a box, I will give in that class notes. Just write it, copy it in your classwork. Okay, anyway, this is the first chapter. It was a very simple chapter. There is no rocket science behind this chapter. Very easy one. So what you want to do? You want to complete, you want to copy all the notes, all the study notes, pocket notes, whatever notes I am giving in that WhatsApp messages. You must copy it to your notebook. Understand? Science notebook. It's better to keep 3 notebooks for physics, for chemistry and biology separate. Even if it is one also, it is fine. So it is better to keep 3 notebooks, okay? One for physics, one for chemistry, and one for biology, okay? So I hope it was an easy chapter. The next chapter we will start from the next class. So till then, okay, my dear students, I hope it was a wonderful day for you. The coming day also, maybe it will be also a wonderful day for you all. Okay, this is Mithun Raj, your science teacher, signing off from this part of the world. Okay, see you later with new chapter. Maybe biology or maybe physics. We will just randomly we will select anyway. Okay, for the next class we will start a new lesson. Till then, signing off. Goodbye. Stay home, stay safe, and Jai Hind, my kids.